It is the 10th time we have these lectures. You are all very welcome. It's nice to see all the students. Today it is Professor Björn Frostell from the Royal Institute of Technology. He's also a member of the Swedish Aral Sea Society that will talk about quantification and sustainability. Slightly more scientific than we used to have it, so to speak. So you have to be very sharp here. And you may remember that Björn Frostell talked about clean production a couple of weeks ago. And so it's his second time he's talking to you. And he has also been following this lecture series quite well. And well, I think that's all. Please, Björn, you may start.
Thank you very much, Lars. And hello, everyone. Can you hear me? Can you hear me in Nukos? No reaction.
Nukos, please answer Björn's question. Do you hear him clearly?
Yes, yes.
Very good. So I will try to then share screen. Now I cannot see here what's happening here. It is like that.
That's right. Yeah, there we are.
I will get to the start.
Mm-hmm.
So there, can you see the full screen now?
Yes.
Okay, then very welcome to this lecture on quantifying or quantification of sustainability, measuring resource flows. And I see now that we have only 17 minutes. I think I will have to pass for the first 30 minutes. I have prepared.
You know, Björn, I think we should do it as we plan. It's just everything will be 10 minutes late.
Okay.
So you keep your 30 minutes and everything will be 10 minutes late because of the internet problem.
Okay, thank you very much. What I will talk about today is about how we can find information that tells us whether we are closer to sustainability with development and not. And the very, you could say, sad thing is that the first conclusion that will be drawn today is actually that we have far too little information of the kind we really need to work at different administrative levels. And in my personal opinion, this is actually because of that economy does not have the scope it requires for the future. It is too narrow in its approaches all over the world. And that's why we are aiming at economic growth without considering the full broad system of ecological reactions and ecological things that go on in the global ecosystem. So I will start there and just tell you that I think this is a very serious situation because the situation is actually getting more serious every day. The first part of the lecture will cover the following aspects: the 17 United Nations Sustainability Goals for 2030. It will also cover how can sustainability in principle be quantified, possibilities and limitations. How is sustainability followed up today? and ecological sustainability as a platform for human activity, as well as social and economic sustainability. And here we have the controversy I already mentioned in my last lecture, that actually present development all over the world is turning this upside down. First economy, then social aspects, and last ecology. We need to turn that around. The Sustainable Development Goals, they were established by the United Nations in 2015. And they look like this. And you will be able to go through in the internet and find explanations of whatever there is. So I will very quickly just go through them all so you can look at them very shortly with a glimpse. First, no poverty. Zero hunger. Good health and well-being. Quality education. Gender equality. Clean water and sanitation. Affordable and clean energy. Decent work and economic growth. Industry, innovation, and infrastructure. Reduced inequalities. Sustainable cities and communities. Responsible consumption and production. Climate action. Life below water. Life on land. Peace and justice, strong institution, peace and justice, strong institutions. And lastly, partnerships for the goals. Here, I would like to mention that in our, so to say, social context culture, I mean, we celebrate Christmas, and then Santa Claus, he comes with a lot of gifts to the kids. And in order to advise Santa Claus what he should bring, so you establish a Santa Claus list, and that are all the wishes a kid would like to have. And in my world, so these sustainability goals, this is, so to say, the global Santa Claus list. And the very hard part of that is that it is very, very seldom, if not never, that you get the whole list. And in my personal opinion, I think that this is a political agreement on what is possible to achieve in negotiations. But I cannot see at all how they can simultaneously be fulfilled. As an example of this, I can mention that just last year, we passed 25 years of trying to fulfill 16 environmental goals for Sweden. And we all know that Sweden is a very lucky country at the moment. We have a high gross domestic product. We have a pretty stable social situation, and we are in a lucky people. 15 out of 16 environmental goals that were established in 1996 to be fulfilled in 2021, they have not been fulfilled. Only one has been fulfilled in the last 25 years. And to me, this is a very clear example. And the government and nobody else really would like to seriously yet to start to discuss how come we could not reach these goals, and how should the global community be able to solve this list of sustainability goals if not one of the luckiest countries on earth had not been able to achieve only 1 out of 16. And actually, we were not to thank for the 16th goal, the safe ozone level. That is an international thing that was solved. The rest we could not solve in our country. So this lecture with the quantification, it will tell you a lot about that. This is something that is terribly serious, and we have not yet any solution on how to fight this. There are new global threats also after these sustainability goals were established. There was a UN report in May 2019, and that says that current global response insufficient. Transformative change is needed to restore and protect nature. Opposition from vested interests can be overcome for public good. Most comprehensive assessment of its kind, 1 million species threatened with extinction. So this is something most people on Earth that are politicians and economists, they talk about now seriously, that we need to combat the climate issue. But that is only one out of several very, very serious things going on. There was another of these reports that came very recently, that 60% of all vertebrates extinct since 1970. So more than half of the vertebrates have been disappeared from the Earth in the last 50 years. Only 2 days ago, I saw a Netflix film called Seaspiracy that talks about fishing in the oceans. And everybody who has seen that film, it takes 1.5 hours, will add this to the list that I am showing here. So how can then sustainability in principle be quantified, possibilities and limitations? And then we can see here the most well-known is the planetary boundaries that Lars has shown already. And where we can see here that the genetic diversity and then the phosphorus and also nitrogen, they have been passing, so to say, the planetary boundaries. So this is what we know, where we discuss all over the world. We cannot pass these boundaries. But any ecologist knows that the first fish we catch in the ocean, the first tree we cut in the forest, it will change the ecological balance. That is a weave of millions, billions of reactions and interferences going on. So that only discussing the limit of extinction, that has, in my opinion, no real sense. There must be somewhere in between the first fish, the first tree, and so on to the limit. But we don't discuss the challenges in this way yet. So here I would like to conclude that the planetary boundary concept, it focuses on emissions from human activities. And it does not consider the primary resource supply, which is the other part. How do we get food on the table? How do we get shelter? How do we get just aspect to what is coming into society and what we need? In Sweden today, the heaviest debate is that how we should combat climate impact by starting new mines and getting more energy so that we can get rare earth metals for the batteries we need. You know, currently we are building one of the biggest battery factories in the world in northern Sweden, where we have cheap now wind energy and water hydropower, and we have a lot of mines and all those mineral resources. Luckily enough, still our legal our laws, they are very bureaucratic, so it takes a long time, and perhaps this can save us from creating an ever bigger problem from extracting these metals and also destroying the northern part of the country. And this is really challenging. It's just these days coming up to discussion that you would like to combat something and then you create something else that is more serious. So in this thing, when we quantify sustainability in the future, me and my students, we have worked a lot with this. You need to talk about the inflows, about the stocks, and about the outflows. And the planetary boundary concept, it has this limitation that it only talks about emissions. It is the metabolic approach where we see what we take into society, that is our food, materials and energy, and we digest it and we create stocks, and then we have emissions, and that's our poo and pee. How then, can this be expressed? What is important? We need food supply, water supply, energy supply, goods and services supply. And the ecological challenges, with some of them only, there should be, I would think, around 20 or so, one could say, very serious ecological challenges. But most important, climate change, biodiversity, waste and wastewater management, and toxicity, biochemical interferences, and plastics. We have also the social aspects. Income distribution, gender challenges, and education. And here we can see a little bit that some of them, they are for sustainability, the entire, and a few of them are more, what I say, diverted or suitable for engineering knowledges and competences. And how do we measure all these things? And that is perhaps the most now challenging part, that how do we get a picture that really reflects the challenges we have? And so far, I argue that in most countries, politicians and decision makers, they listen to the economists. And in the future, they will have to switch this to listen much more to ecologists in the first hand and sociologists and the second. And how do we change this in practice? I think for your students, this is an extremely important aspect to reflect on. And how is sustainability followed up today? So some current approaches. With these now UN sustainability goals, so countries typically have established national sustainable development goals. That is very common now politically. I have not been making any inventory of what countries are saying what and so on, but generally people, they confess themselves to sustainable development. But this means first growth, so that economic growth, so you have resources, monetary resources, financial resources to distribute. And then in second, after this growth, it has now changed. So we talk, for example, in Sweden about sustainable growth. But growth is still here. And every year we can see that on a life cycle perspective, our, impact on the global ecosystem is, more and more negative. So we have not even been able to change the impact on the ecosystems. So what people do now is, since most countries are with the United Nations, so they send in statistics. So there is statistics, but it's collected on a national basis. But actually what happens and need to happen with sustainable development is this, that is manifested from the Rio de Janeiro slogan, think globally, act locally. But we still only think globally, so to say, and then we have not been able to act locally because these statistics and these things, they are not in the type that it helps on a provincial level, on a municipal level, and then at the corporate level and at the family individual level. How many of us do actually know our turnover of carbon dioxide equivalents? How many kilograms of nitrogen are in our personal metabolism? How much phosphorus, sulfur, and so on? We don't know that. Companies don't know that, not very well. And at the same time, if you go to municipalities, I had a student a few years ago that was looking at the environmental work at the EU level, at the Swedish national level, at the Swedish provincial level in the Stockholm County and in a municipality in Upplands Väsby north of Stockholm. And it was like an incredible mixture of approaches and definitions and the way it worked. It was not synchronized. Simply because today we are working international together to get political agreements on what to do and so on, but the practical application of the ecological work under that is very much or very dispersed so far. So now with the UN goals, anyhow, even if they're a Santa Claus list, they are very good in that respect, that it's a start to standardize the work and see that we are doing similar things, and hopefully with similar methods in different countries and in different parts of the world. Here I mention a little bit more what I just said about the different administrative levels. That it's important to stress that methods, standards, and reporting varies a lot from country to country and also in countries and so on. There are attempts going on, but it's still not standardized to the desired level. And very importantly still, so financial accounts dominate the discussion. And this is economic development is still the main force in essentially all countries on Earth. Ecological sustainability as a platform for human activity, as well as social and economic sustainability. And this is from a paper I published some 8 years ago. It's in a handbook of sustainable engineering. And this tries to create a thought path how we should look at sustainability and sustainable development. And this tells that from the beginning, so we essentially had only technical, economical discussions. We wanted technology and human, innovations to help us, starting more or less with how to control fire. And then from the Industrial Revolution, how to organize industrial work and to create factories and produce goods in mass production and so on. And now in the last step, we could say is the digitalization and computerization with information technology. And in this term, so we created the so-called triple bottom line approach, where we divided sustainable development into economic, social, and ecologically sustainable development, but that they were equally, so to say, important. From this in Sweden, we had some 20 years ago or 15 years ago discussion. Should we show this in a slightly different way so that we are beginning to talk about ecology, the ecosystems as our platform of life, and that this is important, and that within that we have our social connections and then the formal economy in the middle. And then at the end, so they are discussed as I'm showing here, that we have a globe system and then we have the human activities, and many of them actually in all countries in the world, they are non-formal. Of almost all household work, for example, that is mostly carried out by women all over the world. That is not counted in any GDP accounts. We know that in all countries, there is also the formal economy and the gray or black economy. In many countries, so it is 20 to 30%, sometimes higher, is informal economy. A colleague of mine in United States, Greg Keolian, and he was actually the global chairman of the International Industrial Ecology Society. He did a study of the US agriculture, how much is formal and how much is informal. And there he turned out that it was over 50% was informal. And that are guest workers from other countries or people that don't have green cards or formal employment in the United States, and they go out and work as workforce in the agriculture. So the formal economy is then in the middle. And that is the conclusion here, I think is fair to have. That is, life on Earth rests on ecosystem functionality. And the very sad thing that you have also experienced, not the least in the Aral Sea disaster, that if we don't care for the ecosystems, so we have no platform to live on. There are no resources to harvest. So with this, I have now very quickly passed the first with a few minutes, but still. And here I would suggest that we have the lecture break, and then I have 2 questions for you. And the first one is, how is progress towards and deviation from sustainability being reported in Uzbekistan and Kazakhstan. So that's the first. And then the second, which are the three most important sustainability-oriented parameters to monitor in Uzbekistan, in your opinion? Now it's coming. Now in the second part, so I would like to go into more of the different types of methods to quantify sustainable development. And I will focus on actually things connected to ecological sustainability, simply because I judge that this is what is very necessary to standardize and get more into the mainstream of political and cultural discussions. And here I would like to show a picture that was drawn already 50 years ago, something like that, for the city of Brussels, which is regarded as one of the first illustrations of an urban area as a metabolic organism that is using materials and energy and is digesting these materials, and then we can see resulting products and also different types of emissions. It is in French, but I still can understand that it is not difficult for you to see how what they're talking about. They're talking about energy up to the left. They're talking about what they import to this area. And then they can also see different types of emissions and exports of different types of materials. And here it is something I think is worth to remember. And that is that first of all, in all these methods to quantify, it is important to create a visual expression of the system that you're interested in. So it's like a map of what different types of activities are going on. And I will show you a later one where I was part of to develop for a new urban area or for a municipality here in the Stockholm region. Also, this to understand and discuss the metabolic activity of a region. So for 50 years, this has, so to say, been in the air, but still it is not agreed on how to do this in practice, to what types of parameters, how should they be reported, what type of information do we actually need for the political and practical decisions. One of the most important things that has happened in the later decades, that is a German system to quantify different types of resource flows. And this is called MIPS, and it's material input per unit of service. And the principle of that was developed by the Wuppertal Institute in Germany. That is that in all these types of systems, so it starts with a type of definition of aim, object, and also service unit, what you would like to discuss. If this is, for example, a car, or if it is a TV, or if it is a food object, and so on. And then we can see that step 2, that is what I showed in the former metabolic picture, a representation of the process chain. So that is, so to say, the map, what you need to establish in step 2. And then you start, when you have the map, to compile the data. And then you both take in this specific MIPS process, you take the material intensity from cradle to product. So that is, for example, if we have a product made of metal, so that is when you have the metal in ore in the ground and you start to mine it and all the processes, transports and so on to produce the metal. and then all the way to the factories or sub-factories where you produce sub-parts of the project and then a product, and then where you put it together to the final product. And the next step is that you go from cradle to grave, and then you include also the so-called backpack, or what is coming after the product is being used, and its wastewater and air pollution is being handled by one means or another. In step 6, you go from material intensity to material intensity per unit of service. So that's a division with the amount of product or service that you produce. And after this, in the last part, you have the interpretation of results and you discuss it. So this is very similar also to a life cycle perspective that I discussed in the last lecture, lecture 7. And here we can see the results. Example of results that is from a publication. At the bottom here, you can see the link, and I visited that yesterday. So if you would read the whole report and learn about the MIPS approach, you can look into this publication that is available on the internet. And here we can see, for example, for electric power, you can see that what they are discussing here, this abiotic resources, and it's calculated or counted in tons per megawatt hour. You have biotic resources that are not in this context of interest. You have water, you have air, and you have earth movements. And that is, for example, the earth movements, that is how much you move, for example, soil from one location to another location, or rock or sand and so on. And then you can see different types of electrical power, both in the Federal Republic of Germany and also from the public supply, the industrial generation. And then you can see the average of the European OECD countries. And you can see that the numbers vary. So here it is a very clear picture that you can see differences. You can also, if you do this on a frequent basis, let's say once yearly, you can see if it is changing in one direction or another. And where these parameters, abiotic resources, biotic resources, water, air, and earth movement, that they are different types of metabolic indicators for the resource use. And this was very popular, actually. It was developed in the 1990s, and it was popular, I would say, for 10, 15 years. Lately, I would argue that this has been adopted more and more into the general life cycle assessment methodology and also the ways it is done. And I will come back to that when I discuss several other methods together with a life cycle assessment method. Here is another thing that can show you also the metabolic approach. It is from a work that we did in my research group, actually 25 years ago. It is for a municipality in Sweden, in Varberg. And here you can see that in this model, the idea is that a municipality is a box. And the box has a wall that is about 500 meters up in the air, in the atmosphere. It is going down 1 meter in the ground. And then it is the surface area of a municipality that together creates the box. And we calculated how much is imported to this box per year in the air, and also from different types of human activities, so on rail and roads, and by other means it was imported, and then with the water, so coming in. And this was nitrogen. So this shows the nitrogen metabolism of a Swedish municipality. And then some very interesting things coming into here is, for example, if we look to the influence to industry, you can see that there is coming 1,100 tons per year and that is to one of the large Swedish pulp and paper factories. And this nitrogen, it is released into the atmosphere as nitrogen gas. But this metabolic activity that is around 900 tons that is neutralized in the industry, it has never before we did this, it was discussed whether this was of value or not. Then we can see at another thing that in the lower right corner, it says waste management. And here we have 150 tons of nitrogen coming out. And down here in this municipality, it spent about between $4 and $5 million to reduce the nitrogen flow by 50% in the municipal treatment plant. But so that you spent money in one corner, very much money, and in another you didn't even count on the metabolism that was neutralizing nitrogen in reduced form, so it was leaving as nitrogen gas. So to us, this proved a thing that people are not actually aware of, how to calculate the different metabolic flows in a society. And this is really one very simple, but still approach how to do and see where do things come from, how the inflows, how are they metabolized in the organism, in this case, the society represented by the municipality, and where does it leave? And then perhaps the most important thing here that I leave to the last is that if you look at the arrows to the left, you can see that the main part of nitrogen, it enters society through services, and that is food and different goods coming into the city. And the main part leaves with the water and with the air. So what man does in all cities on earth today, also in every city and village in Uzbekistan, is that you bring in nitrogen to the city, and then you disperse it to air and water. And as long as you do this, we can say that we pollute. And still, I can say after 25 years, you will find very little information of this type in any city of the world. And actually, we would need to do it both for carbon, for nitrogen, for phosphorus, for sulfur, and for other also types of parameters to understand the metabolic activity of our society that is really extremely complex with a globalized economy. This is another, I showed you the first attempt several decades ago from Brussels. This is for the urban area of Royal Seaport in Stockholm. It's for a city area that is currently under construction for 50,000 people that should live there when it's ready in about 10 years from now. And here is the idea to show the connection. So this is the map of how people in the Royal Seaport in Stockholm, how they are connected to different activities in the world. And this was the most simplified figure that we could develop. If you look at the center of the picture, you can see a family in the Royal Seaport. And then there is about halfway from the center out to the outer ring, there is a green boundary, and this is the geographical boundary of the Royal Seaport. So all activities that are inside the green ring, that they take place into the urban area. And outside of that are the so-called, in MIPS context, the rucksack or backpack activities, or in a life cycle perspective, the upstream or downstream activities. So this picture, it shows in a map of a life cycle thinking based metabolic thing of living in this Royal Seaport. And that means that every arrow here, it has to be quantified if we should understand the metabolism of this urban area. And it has to be quantified for all important parameters. And we have tried actually to do this, and we have published a scientific paper 2 years ago in the Journal of Industrial Ecology in a US journal. And it is so complex that even myself don't fully understand everything that is in there, because there are so incredibly many parameters that need to be taken care of. So one can say it's very easy here to understand that it is very, very difficult to establish a standard where you consider all of these parameters. And here, if we go now to see that what then should principally, where should we start? Then we have been writing here materials, energy, and water. And the reason we did this was that we said that in the world at the moment, the most important discussion is around carbon dioxide and carbon dioxide equivalents as a parameter to indicate the climate impact. So that one should start with. And then one can, depending on the ambition, one can increase the different types of materials. For example, nitrogen, as I showed for the Combox model, or phosphorus, that are two very, very important materials. Phosphorus very much because it's limited and it's mined all over the world. So there we really have to be careful with a resource phosphorus. But for nitrogen, we can also always with energy create the amounts of nitrogen we need. The energy, of course, that is so important. Water, most experts that I talked to in my life, they say that the first real limiting factor humanity will see is water scarcity. But this is not as much on the agenda yet as climate and biodiversity. So here you can see an example of how in the Swedish discussion is on what is necessary to know. And it is a lot, because modern society and modern economies, they are so incredibly complex. A number of tools that are being used to discuss the future and also to quantify sustainability. One of them that is scenario development and evaluation. I will go through them quickly and then show some slides of most of them. We have the strategic environmental assessment. That is a mandatory activity for different types of programs and plans. So if you have very big plans, so you are supposed, according to the EU, this directive, to perform a strategic environmental assessment. That comes in parallel to the environmental impact assessment that is due when you have a project of a certain size. You need to have perhaps from an ecological point of view today, the most influential activity, that's life cycle assessment. I showed the last lecture a picture of the upstream, the core system, and the downstream systems in a life cycle assessment, where you do not only consider what is going on in the specific place or area where you have an activity or a production, but you also consider all the emissions that are upstream in other parts of the world and downstream when you have waste management, water treatment, and air pollution abatement. We have life cycle costing, where we discuss a broader approach to discuss costs for different products and services. We have cost-benefit analysis. That is an economic activity where you value what you get in money and what it costs you. Material flow analysis, very important. It is always a part of life cycle assessment. So in the life cycle inventory, you have a material flow analysis. We have the substance flow analysis. And actually, I've not included that, but in a recent article, that me and 3 of my former PhD students published now just a few months ago. So we have introduced as an EFA, element flow analysis. And that we think is, in some instances, very useful, where you talk about single elements. So you follow their flows through society, and that can be carbon, nitrogen, phosphorus, copper, whatever. PIOTS is something that is of increasing interest in quantification sustainability. That stands for physical input-output tables. And it is actually a way of seeing how you can connect not the flows, but also with the origin and the goal where they are going. I'm coming back to that a little bit later. We have the ecological footprints. And here I put ecological in parentheses because I will show later that there are not only ecological footprints, that are also environmental footprints. And then we have integrated sustainability assessment. And that is a continuously ongoing process, a cyclical process where you come back with regular intervals to look at very many different parameters at the same time. So here you can see there is a whole bunch of different approaches with a focus on ecological sustainability to quantify what is sustainable and what is not. But there is no single one actually yet developed that could help us in order to really say whether we are making progress or not. Here I think is an interesting picture showing the environmental systems analysis, which stands for ESA tools. And here I have been doing for 2009, for 2011, 13, 2018, and now last fall for 2020. I'm simply Googling a number of these environmental systems analysis tools, and we can see how they have increased in use. And very interesting, I think, for everyone to see here that the environmental impact assessment, that is for projects, and they are mandatory in the European Union system. They have increased from very low levels in these 11 years to a very, very high figure. So here we have many, many millions of such studies or hits in the internet. We can say strategic environmental assessment is very low in comparison, although it is mandatory, but it's clear because the strategic projects, they are much, much larger than these single projects. We can see life cycle assessment has also increased very much. It will increase further, but very interesting, we can see that cost-benefit analysis from the economic point or financially economic point, it is the most frequent, what you can find in the internet. Life cycle costing is low. Material flow analysis is not so low, and it's not high because it is included, I think, a lot in this life cycle assessment. Oh, sorry. And then substance flow analysis is still very low. And then you have the other ones that was ecological footprint. It has also increased, but is not as high as the environmental impact assessment and the cost benefit analysis. So a little bit about the dynamics of development, how these different tools are being applied and discussed in society. Shortly about scenario methodology. And methodology, that is a body of methods, rules, and postulates employed by a discipline, a particular procedure or set of procedures. So most of you have an association, but here we have two very clear definitions. A body of practices, procedures, and rules used by those who work in a discipline or engaged in an inquiry, a set of working methods. And then the scenarios. Scenarios, they are attempts to discuss the future and its possible future. So it's not a determined future. And this is because we can never really foresee what will going to happen. But it can be a very good exercise to discuss and compare scenarios. So you can say, what is the most probable scenario? That is perhaps the one of them. And then you put up a best scenario and a worst scenario. This is typical that you set up 2, 3, 4 or something like that scenarios. And then you discuss. And when you do the discussion and compare the scenarios, that's when you learn the most of what potentially could happen. And in this way, you can prepare yourself for the future in a more systematic way. A little bit about a strategic environmental assessment. This was, I mentioned, mandatory for the EU. All plans and programs which are prepared for a number of sectors, there should be used a strategic environmental assessment. So it can be a urban area that is to be developed. It can be, for example, if we not only one airport, but let's say that you would like to plan for how many airports do you need in a city and what is the airports and train stations, when they jointly as a package, then it's a strategic decision. So they are broader than for project. We can see in these areas, they are agriculture, forestry, fisheries, energy, industry, transport, waste management, telecommunication, tourism, town and country planning, or land use. They are areas where you are supposed to perform then a strategic environmental assessment, and you can find more readings. Environmental impact assessment, that was the EU directive for projects. So public and private projects, they are the targets for this impact assessment. And it has been decided already, I mean, early in 1985, and then it has been amended, which means that it has been changed in details a number of times. I have actually not checked recently whether there is a further amendment. Maybe there might be. And the scope here, that is that it's mandatory. All projects listed in Annex blah, 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 are considered having significant effects on the environment and require an environmental impact assessment. That should be under this mandatory rule of creating an environmental impact assessment. And part of this is that you should have a public hearing. So you should gather people from different stakes, people with different opinions, companies or ministries, or what do you say, authorities. They gather in a public meeting, they discuss it, you present the plan, and people are able to say yes or no and discuss. And then it comes into this formal, so there is some type of a jury that will decide whether this project can go ahead or not. And you can read more here if you're interested. Life cycle costing. This is that in the conventional thing is that you not only look at how much is a project in investment and then how much it is in operation, but it is that you take it over the whole life cycle. So you take the investment, you take the operation, you take the maintenance of it, and then you have the end of life, which is, for example, decommissioning and disposal of the residues after you have finished the thing. So this life cycle costing, it can cover a period, let's say, of 20 years or 50 years, depending on the scale of the project and so on. And this gives you another type of information than if you have only an investment cost, for example, and only discuss the operational or production costs. Social benefit cost analysis. This is how do we then discuss these things with, for example, income distribution. If we have equality, equity, and also diversity is coming into education, healthcare, and so on. So how do you then discuss these things? And that is the social part of discussing and quantifying then sustainability. And here there are a number of different, what do you say, approaches and so on. And one of the most important one actually is this cost-benefit analysis. It is very interesting to see also here how one should discuss it. I had a student a few years ago, and then we actually tried to do an effort-benefit analysis. And then we did not calculate with the actual costs, but we discussed from a way of this, that for each individual, the time is the most important part. So we looked at how much time, how much effort is needed, and what could be created in that. Because if we make a cost-benefit analysis according to the standard for it, we should calculate with the salaries in place. And if a Swedish consultant is coming out in international context, typically the charge will be $100 per hour, or could be more, but in that size. And then if you're coming to a developing country, so the salary would perhaps be $5 or $10 an hour. But if they work side by side, who is doing the most effort? They are doing the similar efforts, but one costs 10 times more or 20 times more. How is that really, does it influence on the way we would like to discuss and also take priorities for the thing? And then we found very, very interesting results in sanitation programs in Latin America. This student was from Colombia, and she wanted to introduce sanitation in a poor village. And we thought that this effort-benefit analysis was very interesting. And from a social point of view, I think it is worth thinking about these things, that what do we actually measure and why and how? Material flow analysis, a little bit of terminology. Material, that is how different types of physical entities like, what do you say, sand and gravel and concrete, steel and so on, how they are being extracted, used, and then disposed of. So it accounts in physical units comprising the extraction, production, transformation, consumption, recycling, and disposal of flows of materials. And here we have this, what we call engineering material balances, that they are so important. And the very thing is that since materials not can be destroyed unless in nuclear reactions, so there is also a balance. And that means that the balance should go together. And that makes these balances very strong as a method. Different types of approaches. Substance flow analysis I mentioned before, bulk material flow and accounting, and that can be like sand and gravel and so on, and then material input per unit service MIPS that we talked about before. And then we can see also that this has been tried in different regions. We can see that, as I showed before, for the city of Stockholm and the municipality of Varberg, we can do that also over regions and municipalities. And you should try to connect and interrelate soil, water, and with the other anthropogenic in a holistic manners. So that is, how do we then put the things together? And the things that are so difficult here is, of course, that when we have life on Earth and chemistry, we have also all these kinds of transformations. And how do we then calculate the things when we have transformation? That's why we have suggested that it might be very interesting to have an element flow analysis. Physical input-output tables. They describe the flows of materials and energy within, so to say, the economic system, and between also different economic sectors and the natural environment. So this is a way of trying to keep track of how materials flow, how they accumulate or how they erode, and how they are being emitted to the environment or delivered as products. And again, we have the conservation of matter and energy, first principle of thermodynamics. That's what is the basis for this POTS. And then we have a certain expression. This is internationally agreed that material and energy flow information system. So that's a MEFIS. And it's a data bank of which you can find out for material and energy flows are integrated in a common system. So this is a build up, a data bank where you can extract different types of information. There are, for example, now for the life cycle assessment methodology. So there is an eco-invent database in Europe that is available, and you can make a subscribe for it, and then you can get a whole bunch of different types of basic data that you can use for making these POTS. And the interesting thing with this MEFIS approach that is that you can take better care of and demonstrate where does things come from, where do they go, and in what different types of parameters and flows do you want to divide them into. And the cube that shows a little bit in principle how they are connected, that is to show in a box. And that is an input tables, output tables, and then also input-output tables, which shows the types of material flows that are between different branches. So a very, very simple illustration of this is this part, where you can see on two edges, you can see the inputs and then the outputs. And then you can see on the third layer, you can see the raw materials, and you can see the products, and you can see the residues. So this is a way where you can create then information in a database, and where you can extract it and see where does it come from, where does it go, and what types of materials is there in this thing. So these are the ways, attempts now to create a more comprehensive compilation of information on how to quantify materials and energy in, sustainability quantification. Now the ecological footprint. I'm saying like this, that the ecological footprint is a very pedagogic and illustrative indicator of ecological sustainability. To me, the most important part of this is that it shows now with the pedagogics that the World Overshoot Day, according to this methodology, so it shows that we have less and less time every year, where before we have used up all, so to say, renewable resources for that year. So the pedagogics here is that what the ecological footprint says, that if we, with our current knowledge, should produce our goods and services with renewable resources and in a sustainable way, how much land area do we need? And actually, at the moment, we need more than 1.5 world or 1.5 Earth per year. So we are overshooting that day. And if you recalculate this ecological footprint, that actually is larger today than the land area we have, then we're coming down. And I remember when this was first calculated in 1996, then the World Overshoot Day, it was in November. And now it is around 1st of August. And that has happened only in 25 years. So this is the real pedagogic of the ecological footprint, but it is also so that the way that it is calculated is, so to say, assuming a number of things. So it's the relation between the ecological footprint for 1 year compared to another year that is the really interesting thing. And you can see here that the footprint is compared then with the available land area. And if the latter is smaller than the environmental footprint, the current situation is unsustainable. And for the last 25 years, when this has annually been calculated, we are getting into a more serious situation for every year. So it's increasing every year. Here it says 30. This is a little bit too old. It is now around 50%. It is important to state, though, that the ecological footprint methodology, it has been criticized as being non-scientific and thus not a reliable indicator. And especially here, Robert Ayers, he criticized it heavily some years ago. And he is one of the fathers of, I would say, modern industrial ecology and industrial metabolism. So I must say I am aligned with this, that I think there is a pedagogic in this, but one should be careful. We have other types of footprints, energy footprint, and that can be according to the ecological footprint methodology, but it can also be to the LCI methodology. And that is the approach that is now in Europe, where we talk about different types of environmental footprints. So it is actually not going all the way to an LCA, but to make a life cycle inventory, which is actually the same as a material flow accounting or a material flow analysis. And then one can do also other types of approaches where you collect information around energy production and you see the ecological impacts of it. Carbon footprint, that is pretty well established. And if you're interested, you can go into this link. I checked it and it's still working. And the carbon footprint actually is so that there are many companies that offer consultancy services on preparing carbon footprints. And then another is the water footprint. It started with a Dutch scientist, Hoekstra, in 2005, and then there has been other publications. It has a very, very broad, I would say, ambition, and it is so sometimes so it is interfere also with other types of analysis like LCA. So it's not really interesting, I mean, as such, if you don't have a critical view of what does it say and what does it not say. I think that the best and most important contribution to our knowledge and to the quantification of, I mean, different sustainability aspects, that is that the water footprint has made us aware of that when we import a certain good from a water-rich area to a water-poor area, we also import water. So actually we import and export water with the goods and services that we provide. And this so-called virtual water is very important because it is also a means of coming over barriers of where we have water scarcity. So we can produce a water, what is a efficient thing in a water scarce area and produce a water consuming product in a water rich area and then exchange. And that is part of perhaps the most central part of modern thinking about economy. A very good thing that you can help both areas with this trade of goods of different water intensities. Finally, now coming to the so-called EMA, which is in the course literature for this course for the cleaner production, and it stands for Environmental Management Accounting. And it's combines, it should be physical, I see there's an error here, and financial data in a company. And it is used and should be, I think, an interesting approach in industrial environmental management. And then the physical data includes material and energy input, material flows, products, waste, and emission. This is actually exactly the part that I showed in the 5-6 last slides of my previous lecture on cleaner production. That is the physical part A. The new that is in the B data, financial data here, that are expenditure, cost, earnings, and savings that is related to the different company activities. And there is the reference here if you would like to look at it. I've discussed a little bit with Lars around it, and my opinion is that while cleaner production essentially is talking about the physical data, so here in the EMA, you combine the physical data with financial data, and since in all companies, finances is so extremely important to combine the two to see both where can you get the most for the least money. This is a really interesting thing. The physical flow estimates, they are based on this balance emissions that's equals input minus output. So here I refer to my previous lecture. The EMA, the financial estimates, they can be done in 4 different steps. First, you list all environmentally relevant facilities in the company. So that is both the whole of the company or production unit and the different sub-units, sub-processes in the whole. You find the depreciation for these. So you see how much money should you put away as depreciation each year, because that is a cost then in the economy. You find number of hours of work and its cost at these facilities. So you see these things that you find out really how much it costs you to handle different types of wastewaters, and of gases. And then what you do, what is the systematics, is that you fill in all these financial data in prepared Excel sheets. And then you compare them with the mass balances for the process as such and for the sub-processes. And then you try to identify where can I get the most efficient waste reduction for the least possible cost. That is the idea. Okay, now we're coming to the final slides, and that is quantification of sustainability, an outlook. It's a very, very general outlook and also a personal one. I'm stating that recent work to quantify sustainability increasingly takes a metabolic approach. We need to understand that society works as an organism that eats, so to say, energy and materials, and that is through our human activities. And that this is seeing the whole economy as a large organism where we need to understand and be able to control the physical resource metabolism of the organism. And this is reflected now in different types of buzzwords that you can look into, but most people use them without really knowing what it really means and what it demands. But we have circular economy, eco-cycles, ecological approach, life cycle thinking, and systems thinking. They are very typical buzzwords for this. It is also here important to understand that present-day financial economy not has been able to adequately address sustainability. This should be ascribed to its narrow focus on humans and human activities and neglecting a broader approach and broader systems boundaries. We need not only to include humans in our discussions of how to handle reality. And what this is to me, for you, and here I really direct myself to you as students in this course, there is a fantastic task for students to change this. So the cooperation in the future between ecologists and economists, I think there we have one of these doors to open to get a more sustainable development. Then I have this. This is only a few days old photograph from my farm in northern Sweden. This is a Scots pine tree on my farmland that is almost 4 meters in circumference. So me and my son, we could not grab around it with the best of our efforts. So it's probably around 400 years old. That's a personal estimate. So this is part of what we need to take care of. And the forest is one of the most fantastic ecosystems one can find on Earth. And I really wish that you could establish more forests in Uzbekistan. I think that could only help in creating a sustainable development. And with this, I would like to thank you and close this lecture.